Hello and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to have an introduction to chemical bondings, and we're going to learn something about the ion formation. Our objectives for today are to understand how positive and negative ions are formed, how to relate the ion formation to the electron configuration, and how to solve some problems about the formation of the ions. I saw this image on Google. One atom is telling the other atom, I lost an electron. So the other atom is asking, are you positive? We need to answer this question by the end of this lesson. Now, what is a chemical bond? The chemical bond is the force that hold two atoms together, whether they are in a molecule or any substance. And it occurs by two things, by sharing electrons, which is a covalent bond that we're going to study later, or by losing and gaining electrons, which is the ionic bond. It's a part of our lesson for these videos. The type of chemical bonds, we have the ionic bond, and we have the covalent bond, we have the hydrogen bonds, and we have the metallic bonds. In these sections, we're going to focus on the ionic bond. Before we start the formation of the ions, we need to revise the valence electrons and the octet rule. So guys, I recommend you to go and watch the videos about the electron configuration, because we studied the valence electrons in details. The valence electrons are the outermost shell electrons. And the octet rule, it says that all atoms, they are trying to be stable by obtaining 8 valence electrons in their outer shell, by losing electrons, gaining electrons, or by sharing electrons in order to have configuration of a noble gas. And we all know that the noble gases are the gases in period in group 18, and they are stable because they have 8 electrons in their outer shell. Now, the formation of positive and negative ions. This is a section of the periodic table. As you can see, group 1, 2, and then from 13 to 18. Those are the noble gases, which are the stable elements or stable gases. And we have period 2 and 3. Now, let's talk, for example, about the sodium atom. And the sodium atom, it has 11 electrons. Always when we start studying the formation of the ion, the first step is to write the electron configuration of the atom. So for example, the sodium here, we have 11. As you can see, in the inner, the first energy level, it has 2 electrons. And the second, it has 8 electrons. And the third, we have only 1 electron. So for the sodium, with 11 electrons, is going to be 2, 8, and 1. Now we need to check. The atomic number is 11. That means the number of protons, it equals to 11 protons. And we know that the protons are positive, so it's going to be, the charge is positive 11. And also the number of electrons, it equals to 11, and the charge of the electron is negative. That's why the sodium atom is neutral. It doesn't have any charge on it. And it's called sodium atom because the number of protons equals to the number of electrons. Now, this atom is not stable. To be stable, we need, as we said in the octet rule, we need to have 8 electrons in its outer shell, or 8 valence electrons. But we have here only 1 valence electron. So we have 2 ways for the sodium to be more stable, whether losing 1 electron, and when we lose 1 electron, the outer shell now will be 8, or by gaining 7 electrons. We know that gaining 7 electrons is impossible. It will never happen. So the only way is by losing 1 electron. Now, when it loses 1 electron, the electron configuration for the sodium will be 2 and 8. That means if we calculate the number of protons, nothing happened to them. So it's still positive 11. But the number of electrons now, after losing one electron, it will become 10 electrons, so negative 10. If you add these charges to check the overall charge for the sodium ion, it's going to be positive 1. And we write Na positive 1. We don't need to write number 1, so only positive. So Na is positive. Now this Na positive is not an atom, it's an ion. And it's a positive ion. Positive ion, we give it the name cation. Let's have another example. The oxygen, if you check the oxygen here from the periodic table, it has the atomic number of 8. So also, if we write the electron configuration for the oxygen, it's going to be 2 and 6. 2 electrons in the first energy level and 6 electrons in the outermost, the second energy level and the outermost shell. That means we have 6 valence electrons. We need to implement the octet rule. That means we need to have 8 valence electrons. So that is by losing 6 electrons, or we can gain 2 electrons. Losing 6 electrons is impossible, so the only way is to gain 2 electrons. Now, before, the number of protons, it equals 2 because the atomic number is 8, so it equals to positive 8, and also the number of electrons equals to negative 8, and the atom has no charge, that's why it's neutral. Now, after gaining 2 electrons, the electron configuration will be 2 and 8, and it has an 8 valence electrons, just like a noble gas. And now the number of protons, nothing changed, which is positive 8, but the number of electrons now, it equals to negative 10. So the overall charge, if you add those charges together, they're going to be negative 2. And that's why the oxygen atom is, the oxygen ion, is O negative 2 after gaining 2 electrons. And this is not an oxygen atom anymore, it's an ion because it has a charge. And the negative ion, we call it anion. Now we have cation, which is a positive ion, and we have the anion, which is a negative ion. Let's have the last example, which is the neon noble gas, neon atom. The neon is a noble gas, and we know that all noble gases, they are very stable because they have full outermost shell, or they have 8 valence electrons. So for the neon, for example, we have 8 electrons already. So there is no gaining electrons, and there is no losing electrons. That's why the noble gases, they are very inert, they call them, because they do not react with other atoms, because they don't have to. They already have 8 electrons in their outer shell. Number of electrons, number of protons for the neon, it equals to positive 10 because the atomic number is 10, and number of electrons equals to negative 10, and the neon is always an atom, which is also neutral, no charge on it. All right, let's do this worksheet now quickly. Lithium, as I told you guys, the key to solve those problems is to write the electron configuration and see how many valence electrons you have and how to make them 8. For example, the lithium, we have only 1 valence electron because the atomic number of the lithium is 3. So for the lithium, if we write it, it's going to be 2 and 1. And we need to make it like the helium, so we're going to lose 1 electron. So the valence electrons are 1. Electrons to gain 0, because we cannot gain 7 electrons. We can lose this electron, so the electrons to lose is only 1. And the ion formed because we lost 1 electron. Now the number of protons are positive 3. The number of electrons are negative 2. The overall charge is positive 1, and we call it cation. For the nitrogen from the periodic table, it has 7 electrons, the total electrons. So the electron configuration should be 2 and 5. To make them 8, we can lose, or to make them 2, or to make them full, we can lose 5, or we can gain 3, which is easier. So the number of electrons to be gained are 3, is 3, I mean, and the electrons to be lost are 1, are 0, none. And then the nitrogen will have a negative 3 charge, and because it's negative, we call it an ion. Let's do it, for example, for the calcium. If we check the calcium, we have electron configuration of 20. It's not written here. So let's make, let's say, for the oxygen, the electron configuration of the oxygen, because it has 8 electrons, so 2 and 6. The number of valence electrons are 6. The electrons to gain, we need to make it 8, so we can gain 2 electrons. Electrons to lose are none. And the charge of the oxygen ion is negative 2, because we gained 2 electrons, and it's going to be an ion. Potassium, it has 19 atomic number, so it's going to be 2, 8, and 8, and 1. That is 19 electrons. The number of valence electrons are 1. The number of electrons to gain, none. The number of electrons to lose is only 1. And the potassium ion will be positive 1, and it's called cation. I want you guys to stop the video and try to solve it for all these atoms. I'm pretty sure that you will be able to solve them. Question number 1, if the lithium loses an electron to another atom, why it's written positive 1? All right, it's very simple, because the number of protons, it equals to positive 3. After losing 1 electron, the number of electrons are now negative 2, so the overall charge for the lithium ion, it equals to positive 1. Same thing for the nitrogen. If it gains 3 electrons, so now the number of protons, the total number of protons equals to positive 7. The total number of electrons equals to negative 3. And that is the overall charge will become, sorry, here is negative 10. It gained 3 electrons, so negative 10. And the overall charge will be negative 3 electrons. Let's check now our understanding for this lesson. The first question, those questions, they came in the MSAT in the previous exams. Which of these electron configuration of the atom most likely to lose an electron, 1 electron? Let's check for this electron configuration. We have 1s2, 2s2, 2p6, so the outer shell electrons, we have 8 electrons. That means we're not losing or we're not gaining. It's a noble gas configuration, so it's stable. For the second one, we have in the second energy level, we have 7 electrons, C, number 2. We have 2 in 2s, and we have 5 in 2p. That means the total number of valence electrons are 7 valence electrons, and we need to gain 1. So definitely not B, not A. C, also in the third energy level, we have 7 valence electrons, and then it will gain 1 electron, not lose. Let's check the last one. In 4s, energy level number 4, we have only one electron, so the valence electrons here are 1. So if we lose this one electron, now the outer shell, it has 8 valence electrons. So basically it's going to be D. A positive ion forms before reading, without reading the options. Positive ion, when we lose electrons, it will become positive ion. Losing electrons will form a positive ion. All right. So it should be an atom lose one or more valence electron. Of course, this is the correct one. An atom gain, no, it's going to be negative ion. And for C, electrons are pulled into the nucleus. It never happened. This is incorrect. And the electrons are pushed out of the nucleus. Electrons are not in the nucleus, so also this one is incorrect. The last question, why is the calcium ion Ca positive 2 more stable than the calcium atom? Calcium Ca, it has atomic number of 20, so it's going to be 2, 8, 8, and 2. The calcium ion, it has 2, 8, and 8 because it lost those 2 valence electrons. So this is the calcium positive 2, and this is the calcium 0, which is atom. This one is more stable, of course, only because it has the electron configuration of a noble gas. And this noble gas is, if you check the periodic table, you will find it's the argon, because the argon has 18 electrons, just like the calcium ion. 2 and 8, 10 plus 8 is 18 valence electrons. So it has the electron configuration of a noble gas. Let's check the options. 20 electrons are more stable than 18 electrons? No. 18 electrons are less stable than 20 electrons? No, it has nothing to do with this. The 2 electrons more than the noble gas configuration is more stable. The noble gas configuration is the most stable. So this one is incorrect. The noble gas configuration is more stable. I want you guys now to double check your work here in this table. And I hope you learned something new. Have a nice day. Bye-bye.